Before we enter thermodynamics, we must understand how different gases or how gases behave under different conditions. When we are going to change pressure, volume or temperature, which is known as main variable in gaseous state, then how the gas behave. So as we know, gas have large intermolecular space. Their physical state change easily with pressures and volume. So how the gas behave when we change pressure, volume and temperature? This is known by gaseous laws. There are mainly four types of gaseous law: Boyle's law, Charles law, Gay-Lussac law and Avogadro law. All these combine together and form a combined gaseous law which gave rise to real or ideal gaseous equation. So in this video we are going to discuss about different type of gaseous law. So first one is Boyle's law. At constant temperature, Boyle's law states that at constant temperature the pressure of given mass of gas is inversely proportional to its volume. So we can say that at constant temperature or T, pressure is inversely proportional to volume. From there we get PV is constant. For two different gases or gases at two different conditions, we get P1 V1 is equal to P2 V2. Inversely proportional means when we increase pressure, then volume will decrease, and vice versa. That means when volume is increased, then pressure is decreased. So when we draw graph between P and V, then the graph will be rectangular hyperbola, because PV is equal to constant. Due to this, we get graph of P versus V is rectangular hyperbola. Now we are going to second law, which is known as Charles law. We are going to discuss about the second law, which is also known as Charles law. So Charles law gives relation between volume and temperature. Charles law states that at constant pressure, volume is directly proportional to Charles law. At constant pressure, the volume of given mass of gas is directly proportional to temperature. So from there we can say that volume is directly proportional to temperature. For two different conditions, V1 T1 is equal to V2 T2. This is because we can write V upon T is constant. When we are going to draw graph between V and T, then we get constant straight line. After that, we are going to discuss Gay-Lussac law, which is also known as third law, or its give relation between pressure and temperature. Now we are going to discuss about Gay-Lussac law. Gay-Lussac law give relation between pressure and temperature. So Gay-Lussac law states that at constant volume, pressure is directly proportional to temperature. At constant volume, pressure is directly proportional to temperature. Gay-Lussac law. It states that at constant volume, for the given mass of gas, pressure is directly proportional to temperature. So from this we can say that pressure is directly proportional to temperature, and P upon T will be constant. For gases at two different conditions, P1 T1 is equal to P2 T2. When we are going to draw a graph between P and T, then we again get a straight line. This graph, the slope of this graph will give volume. So now we are going to discuss about Avogadro law, which gives relationship between volume and mole. Mole, the amount of substance. The amount of substance is known as mole. So in Avogadro law, we are going to see the relationship between volume and the mole at constant pressure and temperature. So we are going to start Avogadro law. Avogadro law states that at constant pressure and temperature, the mole of given mass of gas is directly proportional to volume. So we can say that volume is directly proportional to n, where small n is mole. When all these four laws are combined, then they are going to give a combined gas law. Then they are going to give us a combined gas law. So we are going to see what is combined gas law. Before that, we can also say that volume upon mole is constant. For two different gases, V1 and 1 is equal to V2 and 2 is always valid. Now we are going to discuss about combined gaseous law. Combined gaseous law is made by combining Boyle's law, Charles' law, Gay-Lussac law. When we combine these law, then we say relation between pressure, volume and temperature when no variable is constant. So without any further delay, let's start combined gaseous law. We get combined gaseous law by combining Boyle's, Charles and Gay-Lussac law. Now we are going to discuss about combined gaseous law. Combined gaseous law is made by combining Boyle's law, Charles' law, Gay-Lussac law. When we combine these law, then we say relation between pressure, volume and temperature when no variable is constant. So without any further delay, let's start combined gaseous law. We get combined gaseous law by combining Boyle's, Charles and Gay-Lussac law. When pressure, temperature and volume all when we combine all these three laws, then we get PV upon T is constant. PV upon T constant. This is known as combined gaseous law.